Good morning. Magnetic properties of coordination compound. The magnetic moment of a coordination compound can be measured by the magnetic substitution experiment. The result can be used to obtain information about the number of unpaired electrons. There is page number 228 on the hence such area by the metal complex. A critical study of a magnetic of a coordination compounds of the metals of a first transition series will some complications. For metal ion with up to 3 electrons in d orbitals like Ti plus 3, V plus 3, Cr plus 3. 2 vacant d orbitals are available for octahedral hybridization with 4s and 4p orbitals. The magnetic behavior of these free ions and the coordination is similar. When more than the 3d electrons are present, the required pair of 3d orbitals for octahedral hybridization is not directly available. Thus, for D4Cr plus 2Mn, for D4 chromium manganese and D5 manganese and iron, D6 iron and cobalt. Here the vacant d orbital results only by pairing of 3d electrons, which leaves 2, 1 and 0 unpaired electrons. How many? 2, 1, 0 unpaired electrons. The magnetic data agree with the maximum spin pairing of many cases, especially with coordination compounds containing D6 ions. Especially which ions? D6 ions. However, with species containing D4, D6, D5, ions, there are the complications. Remember these points. MnCN6 minus 3. MnCN6 minus 3 has MnCN6 minus 3 has a magnetic moment of 2 unpaired electrons, while MnCl6 minus 3 has moment of single unpaired electron, while F6 paramagnetic means have unpaired electrons with 5 unpaired electrons, 4 unpaired electrons, and C4C2. This has a diamagnetic means no unpaired electrons. And also valency bond theory in terms of the formation of an inner orbital and outer orbital coordination entities, and these two and this inner orbital complex involving which hybridization due to sp3 hybridization form two complexes are paramagnetic and later diamagnetic. On the other hand, these three are outer orbital involving which hybridization sp3d2 and are paramagnetic corresponding to 5, 4 unpaired electrons. And there is an example and limitations of a VBT means valency bond theory. These are very important points for NEET. Star mark. While the VBT larger extent explains the formation of the structures and the magnetic behavior coordinate, it suffers from the following shortcomings. It involves a number of assumptions. It does not give quantitative interpretation of magnetic data. It does not explain the color exhibited by the coordination compounds. It does not give a quantitative interpretation of the thermodynamic or kinetic stability of coordination. It does not make exact predictions regarding the tetrahedral and square column structures of a whole coordination compound. It does not distinguish between the weak and strong ligons. Next video we will see crystal field theory. Thank you. Like, share and subscribe.